Have you ever looked up at the night sky and wondered how the stars twinkling above came to be? What journey did they undertake to reach their current state? It's a fascinating tale, spanning billions of years and showcasing the grandeur of the cosmos. Let's delve into the life cycle of stars. Our story begins in the nebulae, the vast cold clouds of gas and dust scattered across the universe. These regions, often thousands of light years across, serve as the cradle of stars. Forces such as gravity, pressure and temperature fluctuations within the nebulae cause the gas and dust to clump together, forming a protostar. The protostar stage is a tumultuous one. The gathered materials heat up due to the pressure of gravity, and as they do, they start to glow. However, this is just the beginning. As the protostar continues to accumulate more material, its core temperature rises further, eventually reaching a point where nuclear fusion can occur. This is the birth of a star. The next stage in a star's life is known as the main sequence, where it spends the majority of its life. During this phase, the star burns hydrogen in its core, producing helium and releasing energy in the process. This energy is what we see as light and feel as heat. The size of the star during this stage determines its color, temperature, and lifespan. Larger stars burn hotter and faster, while smaller ones, like our Sun, burn cooler and slower. Eventually, the star exhausts its supply of hydrogen. What happens next depends on the star's mass. Smaller stars, those up to 8 times the mass of our Sun, swell into red giants. Their outer layers expand while the core contracts. The core then starts burning helium into heavier elements until it can no longer sustain fusion. At this point, the outer layers drift away, leaving behind a white dwarf that will slowly cool and fade over billions of years. Stars with more than 8 times the mass of our Sun have a more dramatic end. They evolve into supergiants and undergo a supernova explosion. This cataclysmic event disperses the star's outer layers across the universe, seeding space with elements necessary for life. What remains of the star collapses under its own gravity to form a neutron star, or in extreme cases, a black hole. But what does the life cycle of stars tell us about the universe? As stars age and die, they seed the cosmos with heavier elements. These elements in turn form new stars, planets, and even life. It's a continuous cycle of birth, death, and rebirth. Moreover, the rate at which new stars form and old ones die can tell us about the universe's expansion. Observations show that the universe is not only expanding, but doing so at an accelerating rate. This expansion is due to a mysterious force we call dark energy. As the universe expands, the rate of star formation decreases, and the cosmos grows darker, cooler, and more diffuse. But even as the universe expands and cools, the cycle of stellar birth and death continues, creating a dynamic, ever-changing cosmic landscape. So the next time you gaze up at the stars, remember, you're not just looking at distant points of light, you're witnessing the life cycle of stars and the expansion of the universe. A grand cosmic ballet that has been unfolding for billions of